Hello explorers and welcome to another video. Today I'm going to talk about basil, and that's not to be confused with basil, which is a herb used in cooking in Italian and Asian cuisine. So basil, it's a build system used by Google and some other companies with great success. And where I came into contact with Bazel was through TensorFlow, which is built by Bazel. And the really hard thing for me is that Bazel is in a beta stage. It's not really 1.0 yet. And I've been trying to build TensorFlow in Windows with some success and some, well, quite big failures. So I wanted to look into Bazel and see what is exactly Bazel. And Bazel is a build system where you can build a lot of applications in different languages and also be able to connect different languages and build them into your application. So if you have a build that actually takes into account a lot of different languages and you want to build everything in one package or in one build process, Bazel is a good choice for you. So I looked up a little bit what kind of languages you could use in Bazel, and here are some of the ready to use rule set for Bazels. As you see, there are a lot of them. Java and C++ are built into Bazel, so you don't have to have a separate rule base for those. And I think that Python is also very integrated into Bazel, so that you get out of the box. Some of the other ones are more tested or less tested, and some of them are community driven and so on. But as you see, you have a good set of things that you can build in your application. And one thing that I see that I actually didn't mention here, you can actually build Android APKs as well. So you can build iOS applications and Android applications, which is quite nice if you have, let's say, a backend server which is running something, and then you can build your front-end applications in the same build package, and you get a lot of different outputs in the same build. So let's look at some easy builds here. So first off, we have our little prompt here. So I'm using MSys in Windows, and we need to set that up first. So I will add some things after you have installed Bazel. I have talked extensively about how to build Bazel, and you really need Bazel to build Bazel. And in Windows at the moment, you can't really build it from scratch. Otherwise, you have a build script where you first compile it from scratch and then you build Bazel with Bazel, because Bazel has a lot of different languages in it that it actually builds with. So the things I will paste in here is an export to set the Python path where I have my Python executable. I will tell it where my Visual Studio is installed so it can build C++ application, and I will also tell it where my MSys bash is installed, so it has a shell that it can use in the build system. So that's the first things that you need to set up. And then we're going to look at the first simple example here. We have a workspace that is totally empty, and your workspace in Bazel is the place where you actually set up different environment configuration for your build. So you have a workspace where you have a lot of environment things, and then you have build scripts for each of the different libraries or different executables in your build tree. And as we see here, the first example, we don't have anything in our workspace. It's totally empty. And if we look at our build file, it's also very simple. Here we say that we want to build a CC, so this is a C++ application or a C application, and it's a Hello World example. Pretty much easy to see. You have given it a name, Hello World, and then you have the sources helloworld.cc And this is a pretty easy application. It just will type out hello world using very simple C syntax. So we will not go into the specific code, but if we go in here and actually go to the directory, see GitHub examples, C++ tutorial, stage 1, and here I can actually, as this example is in the directory main and it's called hello world, then I will do, I haven't set up a path for my Bazel, so the latest Bazel build 0.5.4, I will link to that directly, and then I will do build, and as we see here, I have my hello world example build file in the main directory. So first off, I will do 3 slashes. In Windows you use 2, in Linux you use 2 slashes, but in Windows you use 3. So the first slash or first 2 slashes are actually to signify that you're starting a build, and then the next is the path. So here we will add the main, and then we will do hello-world. So this says that in the path main you will find a build file, and in that you have something named hello world that I want to build. So after we started to building this, Bazel will actually start up, and it will unpackage everything in the Bazel binary. It will start a Java server that actually does the build process for you, and that call the different binaries on disk and actually does the build. And when this is done, you will have a binary in your Bazel out, and in this case it's an MSVC application, so it's an Visual C application. So this is a fast build, bin main hello world.exe, that's the output, and when I run it, it will say hello world and a timestamp. So that was pretty easy. So let's go over to stage 2, which is the next example here. It's stage 2, and we will look in that directory here. Still empty workspace, nothing in there. So we'll close these down, and we will open up this main directory, and in here we have a little bit more involved build script, because here we have a library. So we will build first off a headers file and some sources, and that will create the library hello greet, and then we will build the binary hello world with the sources hello world.cc, and it has a dependency on the hello greet. And as you see here, you only have colon hello greet and no path before that, because we are actually running it from the same path as we actually have our application in. So the library is in the same path, then we don't need to specify any path. We just say you should take the library name hello greet and use that in my binary. So back to this, and we run that instead. So it's still the hello world application that we want to build. So it takes less time to start up the build process here this time. And when we run this hello world fast build, we will get the same hello world with the timestamp, but in a different different stage. So if we look at the source here, we have this hello world, but hello world is not, world is said in this, but hello is not in this file. It's actually in the greet file. So you have hello and who in the get greet, and then you have this interface, and you use this get greet in your C file. So that's the second example for how to build a Bazel build. So let's go into stage 3 just to make it a little bit more involved. Still empty workspace, And if we go into the main directory's build file, here we say that we have CC library hello greet again, and it has sources and headers. But when we look here in the binary, we actually have hello greet from this directory, and then we say that the path lib has a different thing that we need in our dependencies, this hello time. So if I open the lib directory, there's a hello time build script here that says that you want to build a library in this path lib directory that we call hello time. It has sources and headers, and then you have this visibility. So you say that this main directory or package, so everything in main underscore underscore package underscore underscore will have visibility into this library. So anything in the package main will see this library and be able to use it. So the build process here is pretty much the same. We build a hello world application, we get an executable back, and as you see, Bazel gets faster and faster each time we run it, because some things are already built. So now I build the stage 2 again, which means that you actually have the stage 2 already built. So it will just analyze everything and see, is something changed in this directory? No. So I will only build the things that actually has changed. And in this example, nothing has changed, so it can build it really fast. So we will build the stage 3 now. It will prepare, analyze, and then build this. We still get this hello world application, and if we run it, we will get the same output. Now we have mostly talked about C++ applications, so let's look at some other languages. So some languages that I'm very familiar with is Java. So let's look at the Java tutorial. So we go into the Java tutorial directory here, and the workspace is still empty. And we have this small definition where we have the Java binary, and then we say we want a project runner, which could be the name of the application, and then where our source files for this project runner is. And in our source directory, we have a few different things. We have this project runner where with the greeting say hi. We have this greeting say hi, print hi, and inside of the command line we also have a runner that we could build, which uses the same greeting say hi, and this runner uses the greeter from the earlier directory. But this is very simple, where you build every source file in the example folder, will not use this command line thing. So let's try to do that. We do our build again, and instead of saying hello world, we just say project runner, and it will decompress the Bazel binary and build the project runner. See here, there it starts building. And this will take your Java sources, use the actual Java compiler, and then build a Java binary, and also set up a command file so you can actually run this Java file with the very simple command line. So here we have in the bin directory a project runner file, and if we run that, it says hi. If we look at how this command is set up, we have this command line here. It will look for the bash path and this launcher here, and then it just runs bash with the launcher command and then all arguments. And in this we look for the Java with a lot of different parameters, and then we have It is quite lengthy file, but it's just looking for the Java binary to run with, and then run the specific jar file that we want to actually run in this project. So that's how to build Java application. But we also actually have another Java tutorial when we build a Maven project. So if we looked in this Maven project, we have some things that we set up in our workspace. So now we have something in our workspace. And here we say where our Maven repository is. So we use the UK server, which has a specific URL. We also set up the Maven jar for the UK server. In this case, we want Guava. And in our build here, we have a library that has a lot of different files in it. And it depends on Guava jar. And then we have the binary Maven, Java Maven, which is have the main class of app in the project, my project, and it requires this library we have up above. And we also can test our application with Java tests. And when we run tests here, it will test our application with this test class. So let's try that out. First we have the builder, so we have Java Maven. Let's build that. And this will kick off the Maven repository and actually build using all the Maven dependencies that we are used to from a specific path, and I have already downloaded those. Otherwise it would go out on the internet, look for that Maven dependency, download it, and actually build your binary from that. So this Java Maven file, success1, so it runs that pretty great. We can also build the tests. So this will do the test coverage and actually create a test binary. So if we run that, it will run our test with JUnit, one test successfully run, and everything is fine there. So if we look in the main Java file here in the example, it's pretty easy. We compare two integers and we give the value back which one of them are larger, and in this case A is larger than B, 2 is larger than 1, so we will get 1 back. If it were smaller, we would get -1 back. So that's how compare works. But you probably knew that already. So that's Java Maven example, how you actually set up the different things to download the dependencies required for building with Java. So now we will look at the last directory here, and this is where we build a backend server. So we have one backend server that actually builds a web application that you could deploy to App Engine and so on. And I have looked at this example, I have understood it, I haven't built it or make it work in Windows, because we get some error messages in the build of both the backend and the Android application. In this case, we get the error that in some file in Bazel it doesn't really understand the syntax of two not colons, semicolons. So 2 semicolons means something in the Linux world when you do case, and in Windows that doesn't really work. There is some syntax errors using the double semicolons, so it doesn't work to build on Windows yet. I've tried a lot, but I've built them on Linux and they build fine, except for one thing that I will talk about later. And you also have an Android and an iOS app here, and a CI deployment, which you can play with yourself if you like. The Android will build an APK for you. The iOS implementation will build some of the files and then create a project file that you can open in Xcode and build the last part in that and link it out and build it to an iOS application. So you get very much pre-built for you in order to actually deploy your application on the different platforms. So some things to look in here. We have this build file where we set up some different configurations, and then we have a file group that we can say, if we want to build all, for instance, we say build all the projects. It will go through and build backend, Android, with some conditions here. So that's how you set up to build a lot of different things. In this case, it will build an iOS app depending on which system you are building it for. So it will build backend or Android regardless of system. And then if we have Darwin or Darwin x86/64, it will build a different configuration for you. So this is quite interesting that you can actually set up a multi-project or multi-application build like this. We can also look a little bit into the Android build. You just say you want to build an Android binary. You would give it a name. In this case, they call it Android, but that's the name your APK will get. And custom package, manifest file, the usual. Resource files is defined here. The visibility against other packages, and what dependency we have here. We have activities, which is one dependency. So this is the library which has all the activities for the application. So that's how they have structured their Android application. And another thing that you need to do in order to build this is go into the Workspace, and in here they already have set up some rules for Apple. So they need download some Apple rules in order to build the Apple application, and they have some binary here that you use to build against App Engine. So these are the App Engine rules. So these are two ways to set up downloading an archive from the internet and installing that you need to actually build something, or you use a Git repository to fetch something that you need depending on the commit. And then we have down here some more things for App Engine, but I've put my definition here in the middle. So this is not a part of the original file for this example repository. And this defines where and what kind of Android tool set that you have and what kind of API level you want to build for. So in order to build an Android application, you need to put in this Android SDK repository. You need to give it a name. Android SDK is fine. Then you set a path for where your Android SDK is located. So this name up here is used in the other build file in order to use your repository. So that could be a good name to use for that. Then you need to specify what API level you are using, and that is something that you just choose. It's important that you actually have that API installed, so it actually finds those files on disk. So just look in your install manager for packages for Android, or if you are using the new Maven repository, you might specify that in the Gradle file in order to download the right API level. And then build tools. This is a little bit more strange here, because build tools, in my case, I downloaded the 26.0.2 build tools, but they are still installed in the 26.0.1 folder. So if you want to find out which folder you are using, if we are opening new command window here. So I go into Android, SDK, and then you have build tools. And I'm not sure if you can see, if I increase the size here, perhaps still the name doesn't increase, just the image, but it actually says 26.0.1 here. So you need to look in your Android SDK directory, and under build tools you will have a directory with a specific version name. So it's that name that you need to find in order to choose what or know what build tools you have installed on your system. So that's how you build an Android application using Bazel. And let's go back to my slides here. So this is the caveat that I talked about earlier, that I had some problems building in Linux. And specifically, I have a Gentoo system that I do my work on. And in order to build on Gentoo, I needed to find this file in source, main, Java, com, Google, DevTools, build, lib, Bazel, rules, Python. So the rules for Python, that is bundled in the Bazel there. And then you have the Python stub template txt. So this will build the actual command file run when you are doing Python scripts in your Bazel builds. And this Python script actually had this notation you see here. So it will look somewhere in usr bin environment. So this is the environment command that actually looks what environment variables you have or create a new environment. And then it will run Python as an argument for this environment command. And in Gentoo, that doesn't work. You get a failure on that you can't find the Python binary for some reason. So in my case, I just remove the environment path because my Python binary is actually located in usr bin Python. So I just changed that and this will build. So if we look at this file, I have opened it here. You can see that you have this start of that file where you have environment. So I just remove that, so I get usr bin Python. And then all things will build under Linux. I don't have Xcode, I can't open the iOS application and actually do the last parts to deploy them to an iOS device, but I can at least run the build on that folder. So that was what I was going to talk about today, how to build things in Bazel. So Bazel is a build system to build a lot of different projects in the same build run and keep track on which files that actually have changed. So you do as small incremental builds as possible in order to get a stable build process with incremental builds. So this is built by Google, and I think it's quite amazing that they can build such a large project. Sadly, when you are trying to grab a lot of things and do a lot of things at once, some things works better than other things. So that's why I had a lot of problems with TensorFlow, because there are so many moving parts that something is probably bound to go wrong in that case. I hope that you learned something from this, that you have a greater understanding about Bazel, and maybe you will try to use this in some of your projects. Please give me a comment if you have anything to add to the discussion here. I would love to hear from you. I read every comment and I respond to them. If you haven't subscribed yet, do that. Share, like, and I really hope to see you in the next episode.